Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0843, indicates a problem with the transmission fluid pressure sensor / switch A circuit in the Honda Civic models from 2011 to 2015. This code arises specifically from electrical issues within the circuit rather than mechanical problems within the transmission itself. The transmission fluid pressure sensor plays a crucial role in monitoring the transmission fluid pressure, which is essential for optimal operation of the continuously variable transmission (CVT). This sensor sends real-time pressure data to the powertrain control module (PCM), enabling it to adjust the performance based on the current driving conditions. When this sensor triggers a high voltage reading of 4.84 volts or more, it results in the activation of the DTC P0843. Understanding the origin and implications of this code is critical for maintaining the vehicle's transmission performance and vehicle efficiency. The transmission fluid pressure sensor, as indicated in the Honda Civic, is an integral component of the CVT system. Its primary role is to monitor transmission fluid pressure and relay that information to the powertrain control module, PCM. This data is crucial because the PCM uses it to make real-time adjustments for optimal transmission performance. The sensor is generally located near the CVT assembly, which allows it to accurately measure the fluid pressure in immediate proximity to the transmission. If there's an issue in this circuit, such as the high reading that DTC P0843 indicates, it can result in the vehicle not shifting properly or exhibiting other transmission-related issues. The ability to effectively diagnose the problem ensures that necessary repairs can be made promptly to avoid significant damage to the transmission. When diagnosing the DTC P0843, several potential causes must be considered. First, an electrical circuit malfunction can lead to incorrect sensor readings, causing the PCM to receive erroneous data. This may also relate to a faulty transmission fluid pressure sensor itself. If the sensor is internally damaged or has degraded over time, it might send inaccurate voltage signals. Another common possibility involves wiring issues, such as broken or frayed wires in the harness connecting the sensor to the PCM. It's crucial to thoroughly check the circuit's integrity, as interruptions or interferences can cause misleading fault codes. Troubleshooting begins by verifying each of these components to isolate the problem effectively. The symptoms associated with DTC P0843 can significantly affect the vehicle's drivability. One primary symptom is that the transmission may exhibit shifting issues, leading to difficulty in gear changes or unexpected behavior when accelerating. Additionally, drivers may observe increased engine RPMs, which can lead to a feeling of sluggishness or a loss of power during driving. Furthermore, the engine may not perform optimally, possibly causing stalling or hesitation during operation. Recognizing these symptoms early on can help prevent further complications, such as damage to the transmission system, by prompting timely action. Being aware of the signs enables vehicle owners to seek diagnostics promptly, ensuring not only safety, but also the longevity of their vehicle's components. The first step in troubleshooting the DTC P0843 is to turn the ignition switch to the on position or to press the engine start-stop button to enable the vehicle's electrical systems. This is essential for accessing the diagnostic link connector and using the Honda Diagnostic System, HDS. After turning on, clear the present DTC using the HDS, which resets the fault memory. Following this, check the voltage output of the driven Colli pressure sensor in the HDS data list. It is crucial to determine whether the sensor indicates a voltage of 4.84 volts or more. If it does, You will proceed with the next troubleshooting step, as this confirms that the failure has been duplicated. If the sensor shows less than this voltage, it indicates an intermittent failure condition, suggesting that the system may be functioning correctly at that moment. In such cases, referring to any recorded freeze data to recreate the problem becomes integral to diagnosing potential faults. In the second troubleshooting step, begin by turning the ignition switch back to the lock position. This is essential for safely disconnecting electronic components without causing any electrical shorts. Next, disconnect the CVT-driven pulley pressure sensor 3P connector, which allows direct access to the sensor wiring. Now, use a jumper wire to connect terminals A and B on the sensor connector. Terminal A connects to the CVT-driven pulley pressure sensor 3P connector number 1, which is typically a green-yellow wire, while terminal B connects to number 2, a blue-red wire. Once the jumper wire is securely in place, turn the ignition switch to the on position once again. Check the driven pulley pressure sensor reading with the HDS. If the sensor now indicates 4.84 volts or more, proceed to step 3. If not, move on to step 4. This systematic approach verifies the continuity and functionality of the electrical circuit controlling the transmission pressure sensor. Moving to the third step, it's vital to examine the electrical wiring for continuity issues within the PDN line. Begin by turning the ignition switch back to the lock position, which ensures no electrical components are engaged during testing. Remove the jumper wire used in the previous step, as it is no longer needed. With the HDS, jump the SCS line to initiate the safety check. Next, disconnect the PCM connector B, which typically has a designation of 51P. After disconnecting the PCM, check for continuity between the two designated test points. These test points are 1 and 2, where test point 1 is located at the CVT-driven pulley pressure sensor 3P connector number 2, blue-red, and test point 2 is at PCM connector B, number 39, also blue-red. The test conditions should always ensure the ignition is in the off mode during this continuity check. A positive continuity test indicates that the PDN wire is intact, while a lack of continuity suggests an open circuit that must be addressed. In step 4, the objective is to verify the operation and voltage output of the CVT-driven pulley pressure sensor directly. Start by turning the ignition switch back to the lock position to prepare for the next steps safely. Remove the previously placed jumper wire to return the system to its normal configuration. Next, switch the ignition to the on position once more, which activates the sensor's electrical circuit. Measure the voltage at test points 1 and 2 using a multimeter. Test point 1 relates to CVT-driven pulley pressure sensor 3P connector number 1, green-yellow, while test point 2 measures from connector number 3, yellow-blue. The measurement should ideally present around 5 volts. If this is the case, the sensor is functioning correctly and does not need replacement. However, if the reading is outside the expected range, it is a strong indicator that the sensor has malfunctioned and should be replaced immediately to restore proper function to the transmission system. The final troubleshooting step focuses on the VCC2 line that supplies power to the CVT-driven pulley pressure sensor. Again, ensure the ignition switch is set to the on position while keeping the circuit components disconnected for accurate testing. Measure the voltage between test points on the VCC2 line. Specifically, check from the CVT-driven pulley pressure sensor 3P connector number 3, yellow-blue, to the body ground. The expectation here is a voltage reading of approximately 5 volts. If this is achieved, the VCC2 wire is healthy and properly supplying power. If not, further investigation into both the VCC2 line and its connectivity to the PCM is required. Repair any suspected open circuits within the VCC2 line, ensuring a seamless transmission sensor function. Post-repairs, ensure to retest the system to confirm that DTC P0843 has been resolved, maintaining the vehicle's drivability and preventing potential damage. After completing all troubleshooting steps and any necessary repairs for DTC P0843, it is critical to verify that the repairs were successful. Begin the verification process by clearing any stored DTC codes from the vehicle's memory using the HDS. Following this clearance, take the vehicle for a test drive under various driving conditions. Pay particular attention to the transmission performance, including shifts and RPM behavior, to see if any symptoms previously experienced are present. Additionally, monitor the sensor readings using the HDS to ensure they remain within acceptable ranges throughout the test drive. This thorough verification process helps to ensure the integrity of the repair and confirms that DTC P0843 has been resolved, providing both peace of mind and a smoother driving experience. Preventive maintenance can significantly reduce the likelihood of encountering DTC P0843. Regularly inspecting the wiring connected to the transmission fluid pressure sensor is key. Check for frays, corrosion, or any signs of wear that could potentially lead to electrical faults. Ensuring the sensor is kept clean and is functioning correctly can also prevent unnecessary error codes. Using high-quality transmission fluids compatible with your Honda Civic helps maintain optimal performance and prolongs the life of the transmission components. Implementing these preventive measures, including routine diagnostics, can help in catching any irregularities early, thereby saving on costly repairs and ensuring the reliability of the vehicle's performance. In conclusion, understanding DTC P0843 is essential for maintaining the reliability of your Honda Civic's transmission system. This code highlights an issue with the transmission fluid pressure sensor switch A circuit and indicates electrical faults rather than mechanical failures. Following the systematic and thorough troubleshooting steps outlined will ensure that this fault code is accurately diagnosed and resolved. Additionally, implementing preventive maintenance measures can help avoid future incidents. The importance of regular vehicle checkups, sensor inspections, and proper fluid usage cannot be overstated, as these practices contribute to the overall longevity and performance of your vehicle. By understanding, diagnosing, and maintaining, you can keep your Honda Civic in peak condition. Please like and subscribe to the channel. See you next time.